Okay, because this is a continuation of some of the material. Now we are looking now at the database implementation. Now at this point, this module just introduces some of the concepts about SQL Server, a bit about the history, the definition of SQL, the standards and vendors, database systems and the components to them, the 4 core components, hardware, software, users and data, and the structures of a database system in terms of the architecture, the various different hardware, those hardware, software, users and data is mentioned quickly. And then there's a mention about the database system metrics. What is the most important feature? How do you test the database? You're looking at these 3 guys. The availability, performance, and integrity. Availability, talking about is the data available, access, can you access it? Then the performance, how quickly does the system process your request and return your result based on that? And the integrity ultimately is your data which you're seeing valid, accurate, and up to date. Okay. Which of these is the most important one? In my opinion, yes, all of them is important for a system, but to really, if you are looking at a bank system or any real database where it's required, the integrity is more important. If you display data to someone, even doesn't matter if it's on time, the performance is there, but you display incorrect information, you are going to have a few angry customers. So if something goes wrong, there's a few targets and penalties to this: loss of income, loss of customer confidence, and it can mean that there's monetary, as in money, penalties, that you start losing money. Okay. So there is a bit of mention about how the SQL Server instances is structured in terms of the server, the instance, how it's composed, the database, the logical structuring in it. And then they mention it for us in a diagram to say to us, but we can have one actual server, Microsoft SQL Server, which is running. We can have multiple instances on that actual machine. But for each instance, you will have your own, it will have its own system databases. And then you can have user-defined database, however many you would like to have. That can be expanded depending on your instance which you are working with. Okay, so then they mention the logins, users, and roles, and the difference between each. So our logins is really authentication record, really to access the database services, and is divided into 2 main portions. For example, SQL Server authentication or Windows authentication. Okay, then your user is the actual person who is now accessing the database. That's its a final level of granularity. Okay, our roles define the role which the person might be playing and performing on that database. Okay, then there's a mention about the schemas. Now we've looked at schemas when we created the physical data model. It's really a container for your related database objects, providing them a distinct namespace and working from there on. It also gives you access control to that specific schema. Then there's a mention about tables and what is required to create a table. Okay, so for each column, we at least need to have a data type, the length and size, the nullability as a null or not null, and possible default values you can also have. Now, Then there's other things which we might go and define in terms of the primary keys, the foreign keys, check constraint, triggers, indexes. Those are other things that can be added to a table. Okay. Then you can also have, for example, virtual tables. They do not really contain any data, but they are prepared based on some defined query for you. Okay. Then there's a mention about store procedures, which is really just a small program for SQL Server, and also use-defined functions. This allows us to do some modular programming where you create a small module where you can call it with some input parameters and it can return specific things for you based on that. Okay. Then we have the different types of statement categories, as in data definition language, DDL, to ultimately go and create things. What I like about commands like this is what you tell it to do, that's what it's going to go and do. In this case, create. What are you creating? Table. If you wanted to create a database, it would have been create database. Simple as that, with actual name to it. Yes?
Isn't that put inside the schema, that create function, create tables?
No, not per se. Because before you can have a schema, you need to actually at least have a database. Then you can go and say create schema and the actual name of the schema. But for everything which you are creating as a structure, for example, tables, we can go and modify that. That's why the alter command is there. To now say, but we are changing this. Okay. That is especially useful for tables and changing columns and adding columns and primary keys and foreign keys and so on. Okay. Then we have data manipulation language to actually allow us to manipulate and insert records. Okay. And then to possibly go and update an actual record, and that's at row level. Okay. And then also to delete one. Okay. Then we have data query language to allow us to query and retrieve the actual data from the database. That is based on just a plain select statement. Okay, then there's 3 other categories also. Data control language, transaction control command, and database administration commands, which we're not really going to look at in this case. There's also examples to the data definition language and to go and create, manipulate, and insert data. Then the data query language to actually retrieve data for some record. Okay. Now, that was part of the first module. The second module then talks about actually going and creating a database structure. But before we can look at that, we need to look at the actual naming conventions and using and whatever we do to be consistent and conform it and in some way to use some proper indentation, to use a professional approach, because later on you might need to look at your stuff again so that when you look at your code you can make sense from it. Okay. Now, there's some rules for naming database objects in terms of the length and what can you have for regular and delimited identifiers for the length of that. I personally think that you have a problem if you are going to name something 128 characters long as the name of your identifier. You need to reevaluate it a bit. Okay. There's also then the characters, what can you use at the beginning of each identifier. Okay, you will see there's, for example, we can have an @ sign, but that tells us really that we're working with local variables or parameters inside that section which we're creating. Then we can have an identifier that starts with a number sign. That really tells us that we have a temporary table or even a procedure there. Then we can have a double hash assign, talks about global temporary objects, and then we have the at also, which talks about SQL Server functions that we can access from there. Okay. Then there's other rules which we can define for subsequent characters after the first one. Okay, guys, you can review this to see what can you use for naming attribute or columns and your tables. Okay. Now, a lot of times it also happens that when we name something that we might or want to delimit it. Delimited means that you are going to apply either quotes or square brackets to it to give you the ability that you can actually use that text or that name as you totally want to use it. Sometimes there's a case that you might want to have a number or a space in between words. And you can't just use it directly, so you need to delimit it. There's also cases where you have reserved words. For example, order and users in a database is reserved words because they are already created there, you can't use them. So if you now want to create an order table, you a lot of times will either place an S at the end to make it orders, or you can delimit it and use it like that. So there's examples to delimiters, and they've delimited my table and orders also. And then there's examples about going to create a database, an actual name of the database. There are a lot more options to this which you can possibly have. But that is really just the basic syntax to go and create a database object or a database. Then when you're creating tables, what are we starting to see? But you can now go and say, create table, and then you can start to give this table a name. Then when you open the bracket to tell this guy, but this is the columns that I'm having, I can now go and say, this is the name of my column, the data type, the length which I possibly have, the nullability that is associated to that. Okay, and then you can put a comma separated list to just say this is the next column, next column, next column. Okay, and ultimately close it with a bracket. Okay. What you need to note from this, each of your columns must still have a valid name, valid data types and length. Otherwise, it will not compile for you. Okay. Now, here at the bottom is an example where they've created a primary key for one column. Now, that primary key at this point is only allocated to column 1. It's not a combination of columns also. Okay. Now, there's an example where they're continuing with this to create a composite primary key. What is a composite primary key? It's a primary key which is composed of multiple columns. Okay. Where do we see it a lot? We see it in associative tables, because we're seeing the primary key from these two come together. And in this case, it's a constraint, the name of the constraint, primary key, and then you place in your round brackets the columns which is part of the actual primary key. Okay. Now, what you need to note from this, there is only one primary key allowed per actual table.
So there, the constraint is the primary key.
For the
composite primary key. I'm saying the constraint, the column, is the primary key.
yes, because constraint, there's different types of constraints which we have available.
So it's just
constraint is a keyword to tell us this. We are having a constraint, and then we're giving it a specific name. if you created the primary key using the previous example, it would actually give it a strange name which you can go and look up in the database objects, and you will see, but there is a primary key with a funny naming convention to it. But if you do it this way, you can define what should be the name of your primary key. It can also be composed just of one column. It doesn't mean that you need to have multiple columns there.
When you go look up now, do you include both columns, the both columns that make up the...
When you go and do lookups,
Yes.
okay, keep lookup, I'm talking you're referring to foreign keys.
Yeah.
We'll get there now. Okay, so there's a bit of information that you can go through a bit more. Now, there's some information about modifying your table structures, adding columns and removing columns, modifying your actual columns and primary keys and foreign keys and adding a foreign key even. Keep in mind that when you modify it, what are you doing? You're already changing an existing structure. This is not a database manipulation language statement. It's not an insert, update, or delete. This is an alter table statement because you are making an actual change to this. Okay. Then there's a mention about creating views. Now we'll get to this again, but a view is really a virtual table which we're seeing, which is really a virtual view of data which is defined by your select statement. Then the other options which we have is to go and say drop database, or drop a table or a view. Drop is not to kick it, but it is to remove it, to totally remove it. Now, a database is not Windows. It's a Microsoft product. It doesn't nicely ask you, are you sure? If you've typed it and you've executed the command, it's gone. Okay, except if you have proper transactions and backups and so, which you can use to get back at that point. Okay. There's a mention about renaming database objects with a store procedure called sp_rename to rename it, but there is also problems because you can get to a place where it gives you quite headaches because it doesn't go and change any concurrent references to that thing. Okay, now creating primary keys and all of that falls really just on the concept of entity integrity, but we also have referential integrity and domain integrity, where your domain speaks about the scope of an actual attribute and the column and so. So what we see from it is the domain name, the meaning, the data type, the size, the length. So there's also mention about the check constraint. Check constraint can, for example, go and check for us if this is matching specific conditions. Okay, so you can go and define specific conditions based on that. You can even have a like operator to say, is this text in this column based on specific characters? So that when you do this, so that you can limit it to specific possibilities. Okay. There's an example on using this or to check if the ID is between 0 and 10,000. So that every time that you insert a record into that customer table, your ID field must be between specific ranges. Okay. Okay, guys, there's also mention about using primary key versus unique key constraints. And you can have a look at that. Again, there's a continuation of the primary key portion. Then they mention unique keys. Now note about this is you can have multiple unique key constraints per table. Okay. Unique key constraint is almost like having an alternative field which can be used as an additional identifier for this table. Okay. It's extra. Okay, and it can still be composed of other columns also. Okay, so there's a matter of how is it created, there's an example to it. Okay, then they mention foreign keys. Now, a foreign key allows us to refer one table's records back to another table. So in this case, we have part to vendor. This vendor ID we know is a foreign key, but to where? It's referring back to vendor. If we go and write those statements, which of those tables must exist first before we can create the foreign key? Vendor must at least exist because we would like to point to that guy. I cannot point to something if that something doesn't exist yet. Similar to the chicken and the egg example. Okay. So here's an example where they're creating a foreign key and the syntax to it. What are we seeing? It's just constraint, the name of constraint. Earlier we had primary key, in this case we have foreign key. But now we're taking this foreign key as a specific column, column 1. Now we're saying, but this column refers to, references another table, the name of that table, and then the column which it's referring to. And if you want to go and alter an actual table to add a foreign key, here's the actual syntax to that. So then they have a basic example where we have the part in vendor 1 and they would like to create the foreign key. But what we can see from this, we can also go and say vendor ID references vendor ID. Keep in mind, this is the part table. Parts table refer to the vendor table. And this is now saying, but my vendor in my parts table refers to some other column. Okay. So with every foreign key, you might need to make decisions based on some constraints which you have. Now the possibilities which we have is, for example, let's say cascade, no action set null or set default. Cascade means that if I remove my primary key side, let's say I remove my vendor, it's also going to remove all parts which was sold by this vendor. Okay. So no action means that if I try and remove the part and there's a vendor which it depends on, it won't allow that to happen. Or vice versa, in any case, if you try and remove the vendor and there is parts for this vendor, it will stop you from removing it. Okay. Set null, if we would like to now remove the vendor ID in the part is going to be set to null. But that might create a problem for you depending on your choice about the nullability of that particular column. Okay. The first time it might not be a problem, but the second time you try and remove something, it will give you a problem on that. The set default, it can also mean that we go and set the actual value to something new. Okay. So here's examples where they've just mentioned how does it look if we look at a diagram like this. There is U and C on update and on delete. So on update, at this point it says to us R for no action, and on delete it's going to cascade my decision on that. Okay. So here's also just an example how they're adding that particular options to the foreign key creation statement. Okay, guys, you will see there is an example where you are now required to go and create this database structure. Okay, what I understand from it is that you are going to go and create the actual database and then submit your code just to prove that you have done it. You've played around, you've struggled a bit. It's there. Okay, just as I mentioned, I want to quickly just show you on this. If you open up SQL Server, this is also on the virtual machine. You'll see it there at the bottom. You can use the Windows authentication, tell it to connect. Okay, now in that, it gives us the actual database structure, and on that we will have our databases, which is in this point just our system databases. Now you need to go and create a new database. How do we do that? There is an option just to go and the old approach to say new database, but the quickest approach is just to go and say new query and then to type it in. Create database and the name of the database. So for example, create database test. If I execute this, it goes off and it actually goes and created it. So if I refresh this, we will now see that I have my test database. Now, at the top there, you'll need to note that I'm not using the test database yet. There at the top, I have a selection about what database do I want to use. So I can go and tell this guy, but I want to use my test database. So I can also go and type use test, and if I now select that portion, it will go and execute it. It will go and change it to my test database for the connection. Okay, what happens if I try and run all of that again? Okay, if you do not select a specific portion of code which you would like to run, it's going to assume that you would like to run everything. It's similar to a procedural language where it takes that all the code which is there, not just a small selection, is then going to be executed. So if I only wanted to run this statement, I can go and select it and go execute. Okay.
So by creating the database, you are repeating it.
By creating it and pressing execute again, you are telling it to try and create it, and it's already there. Okay, it happens a lot that we create something and we just press execute and it's there.
Would you have like a fresh new database?
No, it will not. No, even if there's data, it will not just overwrite it. Places where this is getting interesting, if you, for example, have update or delete statements in your batch, because this whole query is seen as your batch window which you can then work with, except if you start separating it with go statements. But still, it's better to... Yeah, no. You can. So you can, for example, have two dashes, or you can have a slash and a star. So that's a multi-line comment. That's just a single line comment. So those are things which you can still do. Okay. Guys, I believe you should be able to go and write the create table statements. I just wanted to show you how to connect to it, how to do it. Any questions?
About the last section, when you're saying when the table you are deleting something, you want to drop another table, something, you want to delete it.
Okay, keep in mind that that is more talking about foreign keys. It's not talking about dropping some structure. Okay, drop.
I was saying delete.
Okay, yeah. Delete more talks about, let's say we want to remove specific rows from one table and that's being referenced in another one. So I can't just delete the primary key on which it depends.
You built in that mechanism on when you are creating the tables and columns.
Yes, keep in mind that when we're doing this, if I do not assign this, and I do not tell it what to use for on update, on delete, it is going to assume no action. No action means that if I try and delete my primary key, and there's foreign keys which it depends on, I cannot do that. Okay, it won't allow that action to happen. Even for update. Yes, even for updates, you first have to go and change the children. Then you can change the parent. Okay. Any other questions? Don't think so. Okay. That's it. Thank you.